grade 10. Welcome to Valenzuela Facebook Live, where science learning is truly amazing. On the previous discussion, you have learned the contributions of the different scientists to the development of electromagnetic waves. Their scientific contributions helps us to understand the different characteristics of electromagnetic wave. We all know that there are 7 electromagnetic waves, and it is arranged in the EM spectrum based on their wavelengths, frequency, and energy. Well, in today's discussion, we are going to cite practical applications of the different regions of electromagnetic waves. Specifically, we are going to cite applications of radio wave, microwave, infrared, and visible light. So, before we start our discussion, let us have a short recall of the previous lesson. I will flash statements about EM waves, and you will determine if it is true or false. You are going to hit heart react if the statement is true, and sad react if the statement is false. You will be given 5 seconds to react your answer. So are you ready? All right, let's begin. First statement. In a vacuum, the speed of electromagnetic wave is equal to the speed of light. Is it true or false? Heart react or sad react? 5 seconds, go. All right, so the correct answer is true. Let's have the second statement. Microwave has the shortest wavelength of all the EM wave. Is it true? Heart react or false? Sad react. 5 seconds, go. All right, time is up. The correct answer is sad react. So the statement is false. Remember, gamma ray or gamma radiation has the shortest wavelength of all the EM waves. Now let us have the third statement. Infrared has a higher energy compared with a radio wave. Heart react or sad react? 5 seconds, go. All right, so time is up. The correct answer is true. Now let's have the fourth statement. Radio wave has the highest frequency of the entire electromagnetic wave. Is it true or false? 5 seconds, go. All right, so the correct answer is sad react. It is false. Remember, radio wave has the lowest frequency and energy of the entire electromagnetic wave. Now let's have the fifth and last statement. Infrared has a shorter wavelength compared to microwave. 5 seconds, go. All right, so the correct answer is true. Heart react. All right, so good job, students. Well, can you give a heart react to all who participated in our activity? All right, so at this point, we will now discuss the different applications of electromagnetic wave. Are you excited to know how EM waves affects our daily life? Well, let's start with the radio wave. So radio wave has the longest wavelength in the electromagnetic spectrum. In 1886, Heinrich Hertz, a German physicist, applied Maxwell theory on an experiment and became the first person to transmit and receive controlled radio waves. And because of the discovery on radio waves, wireless communication over large distance became possible. The transmission and reception of radio waves are one at a time. First, sound waves enters the microphone and are converted into electrical impulses. The electrical impulses of sound will be transferred and taken into the transmitter. At the transmitter, amplitude modulation is being carried out on its output. High frequency voltage is generated and creates current in the antenna. Electrical impulses are converted into radio waves and spreads out through the ambient space. The radio waves reach a radio receiver and converted back into sounds by a loudspeaker. That sound is exactly the same as the sound acted upon the microphone, and this is how we were able to listen to our favorite songs and our favorite radio stations. Now, radio wave has a wide range of wavelengths. The whole region of radio wave is divided into 9 smaller regions or wave bands. Each wave band is allocated by law to a specific radio service. This is why we have different radio stations such as 90.7, 101.9, and different channels such as Channel 7, 21, 5, and many more. The wavelengths of radio waves are the following. We have extremely low frequency, very low frequency, low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and extremely high frequency. Now, let's identify the uses of these 9 bands of radio waves. Let us start with ELF, or extremely low frequency radio wave. ELF, or extremely low frequency radio wave, has the lowest frequencies and longest range. It is useful in penetrating water and rocks communication. It is used in submarine communication and inside mines and caves. Next are low frequency and medium frequency bands. These two are used in marine and aviation radio as well as commercial AM or amplitude modulation radio. Next, we have the high frequency, very high frequency, and ultra high frequency bands. These are used in FM radio, broadcast television sound, public service radio, cell phones, GPS, or the global positioning system. Take note that high frequency waves can be reflected by ionosphere. This enables the waves to be transmitted over a great distance. Now let's have the super high frequency and extremely high frequencies. These are sometimes considered as part of microwaves. These radio bands are less affected by air and is sometimes used for short-range applications such as Wi-Fi and Bluetooth. Well, radio waves is very useful to us. Imagine life without waves, or imagine life without EM waves. Well, thanks to the discovery and the development of radio wave. Now, let's discuss the applications of microwaves. Microwaves have smaller wavelengths compared with radio waves. Microwaves are used in satellite communication, radar, television transmission, and in cooking. Microwaves can penetrate the atmosphere of the Earth. This is the reason why they are used for satellite communications. Communication satellites travel on Earth at an altitude of 35,000 kilometers per hour and revolve around the Earth every 24 hours. Yes, the same rate as the rotation of the Earth, and this makes them appear to be stationary or not moving when seen on Earth. So, how satellite communication works? The process of satellite communication begins on Earth station designed to transmit and receive high-frequency signals from satellite in orbit around the Earth. The satellite receive and retransmit the signal back to Earth, where they are received by other Earth stations in coverage areas of satellite. The transmission system from the Earth to the satellite through a channel is called uplink, while the system from satellite to the Earth station is called downlink. Microwaves are also used in radar. Microwaves are also used in radar. Radar is acronym of radio detection and ranging. Radar system consists of an antenna, transmitter, and a receiver. So how it works? The transmitter sends out a narrow beam of microwaves in short pulses. A distance object reflects some of the signal back to the receiver, and the direction to which the signal receives gives the direction of the object. And the distance of the object are calculated based on the time difference between the transmitted pulse and the reflected pulse. And this is how a radar works. Now, have you seen this kind of vehicle? Well, you will see it when there are live news coverage in an area, and it uses microwave. Microwaves are also used to transmit television news coverage from a mobile broadcast vehicle, just like this one, back to the station. And another application of microwave is a cellular phone. A cell phone is a radio transmitter and a receiver that uses microwaves. Cellular phones depends on an overlapping network of cells or areas of land several kilometers in diameter. Each cell has its tower that receives and sends microwave signal. Cell phone signals are carried through the air as microwaves. A cell phone encodes the sound of the caller's voice in a microwave by changing the frequency of the wave. This is called frequency modulation. The encoded microwaves are then sent from the phone through the air to a cell tower. From the cell tower, the waves travels to a switching center. A mobile switching center is a core part of the GSM network system, and it acts as a control center. From there, they go to another tower or cell tower, and from the tower to the receiver of the person being called. The receiver changes the encoded microwaves back to sounds. And this is how we were able to call our loved ones to say hi, hello, I love you, and I miss you. Well, thanks to microwaves. And of course, the most obvious application of microwave is a microwave oven. So how it works? Well, in a microwave oven, the food absorbs a certain microwave frequencies. The microwaves penetrate the food being heated. It will agitate the water molecules within the food, thus creating molecular friction, which then produces heat that will cook it. So now we are done with microwave. Now let's have the next type of electromagnetic wave. So we are going to discuss infrared. Infrared was discovered by Sir Frederick William Herschel in 1800s. It is a type of radiant energy that is invisible to human eye, but we can feel as heat. It is emitted by all objects, and the amount of energy and wavelength of radiation depends on temperature. Our bodies radiate infrared, and under night vision goggles, it appears in variety of colors. The difference in color determines the difference in temperature. Take note, the shades blue and green indicates region of colder temperature, and red and yellow indicate warmer temperature. Other useful application of infrared is on weather forecasting. Himawari 8 is a geostationary weather satellite that makes high-frequency infrared observation image of Earth. It was installed at Pag-asa last December 2015. It is the most utilized satellite imagery in real-time weather forecasting, tropical cyclone analysis, and even for research purposes, as it generates image every 10 minutes. Now, this is an infrared satellite image from Weather Bureau Pag-asa, which shows the position of Super Typhoon Yolanda covering almost the entire Philippines. While this image is DOST Pag-asa Himawari 8 IR or infrared image of the Philippines. This photo was taken or was captured last night, January 12, 2021 at around 10 p.m. This photo was grabbed from the Pag-asa website. Now, we usually see these images on a weather forecast being used by an expert meteorologist to clearly explain to us weather conditions. Another application of infrared is on remote control of our home appliances like TV, DVD, and air conditioning system. And did you know that infrared plays an important role in preventing spreading of coronavirus? Well, IATF mandates that every person that will enter every establishment must be checked for symptoms of COVID-19. Thus, infrared scanners are used to show temperature variations of the body. Well, every day, everywhere, infrared is used. Next is visible light. So when light passes through a prism, it continuously changes from red to violet. Remember that our eyes are sensitive to electromagnetic wavelength that ranges from 4 times 10 raised to the power of -7 meters to 7 times 10 raised to -7 meters. This is the range of wavelength of white light. And these are the wavelengths of the different colors that constitute the white light. One of the most important applications of visible light is laser. Laser stands for light amplification by stimulated emission of radiation. Laser emits through a process of optical amplification. And because of the development of laser in 1960, optical communication became possible. So, what is fiber optics or optical communication? Due to internal reflection, light can travel inside a fiber optics cable and can send information through this method. Fiber optics are long, thin strands of carefully drawn glass about the diameter of a human hair. These strands are arranged in bundles called optical cables. We rely on them to transmit light signals over long distance. And in 1970s, the first optical fiber telecommunications system had a data rate of 45 Mbps. Now, the performance of optical fiber and data rate was improved, and as a result, it can now exceed up to 10 terabytes per second. Which now, let's compare copper cable and fiber cable. Which is better? So I'll be giving 5 reasons why IT professionals choose fiber optics. First is fiber optic transmission is faster. The standard way to measure data transmission rate is via bandwidth. These days, it is measured in gigabits of data per second or even terabits per second. Next, fiber optic transmission can cover greater distances. While both copper and fiber-based signaling suffers from attenuation or weakening of the waveform signal over distance. However, fiber optic cables can transmit data over much longer distance, and in fact, a huge difference between the two. And third, fiber optic cables are resistant to electromagnetic interference. Fourth, it saves space and enhances cable management. Fiber optic strands are extremely narrow. In fact, they are measured in microns or millionth of a meter. The most common fiber optic strand is the same diameter as the human hair. Yet it is so thin, yet as we've seen, they can transmit incredible amounts of data at much higher speed over much longer distance than their less narrow copper counterpart. And last, fiber optics are future-proof. Every year, the amount of data we consume increases, as do bandwidth requirements. Now, investing in a modern fiber optics cabling infrastructure will allow your network to operate at future speeds without replacing the cables. So fiber optics is important in telecommunications and is now used across the globe by many telecommunication companies to transmit telephone signals, internet communication, and cable television signals. Thanks to the development of optical fiber, because we have a faster internet connection that we are actually using right now for this Facebook live stream. Thanks to visible light, and again, thanks to electromagnetic waves. All right, so at this moment, let us have a short activity to summarize our discussion. On this activity, you are going to identify what is the object inside the box. So I will be giving 3 clues, and you have 10 seconds to guess what's inside the box. Are you ready? All right, let's begin. So let's have the first item. So these are the clues. This item can be found at home or even inside a car. This device uses electromagnetic waves for communication. And third clue, this device has different wave bands allocated for a specific station. So what's inside my box? Key in your answer on the comment section. 10 seconds, go. All right. So the correct answer is a radio. All right, good job, students. Now let's have the next item. Second item. It can be found at home or in restaurants. Second clue, it works by agitating the water molecules within foods. Third clue, of course, it uses EM waves to function. Key in your answer on the comment section. What's in the box? 10 seconds, go. All right, time is up. So the correct answer, the object inside the box is a microwave oven. Now let's have the third item. First clue, it is a radio transmitter and a receiver that uses EM waves. Second clue, it is important in our daily lives for communication. And third clue, it depends on overlapping network of cells to receive and send signals. Key in your answer on the comment section. 10 seconds, go. All right, time is up. The item inside the box is it's a cell phone. All right, so let's have the fourth item. First clue. It is a device that emits light through a process of optical amplification. Second clue. Some of its uses are the following: optical disc, fiber optics, and printing. Third clue. It is also used in some beauty treatment such as hair removal. Key in your answer on the comment section. What's in the box? 5 seconds, go. All right, time is up. The correct answer is, okay, so a laser. Now let's have the last question or the last object. This device is required in all establishments due to pandemic that we are experiencing. Second clue, this device is used to identify potential patients of COVID-19 and prevent them from entering crowded establishments. Third clue, this device can be handheld or mounted to prevent close contact. So key in your answer on the comment section. What's in the box? 5 seconds, go. All right, so time is up. The correct answer is a thermal scanner. Great job, students. Now, can you give a thumbs up to those who participated on our activity? All right, very good. So at this moment, you can now comment your questions about the topic that I have discussed, and then the teacher moderator will choose 3 questions from the comment sections. I'll be giving you 30 seconds to key in your questions. All right. So at this moment, let me read the questions that the teacher moderator have chosen. So let's have question number 1. What are the other application of laser? So laser is very useful to us. It is used in different industries, such as in medical field. So laser is used to improve vision during eye surgery on the cornea. It is also used to remove kidney stones and even to remove tumors. So let's have the next question. What is the function of satellite? So satellite plays a vital role in global communication. There are approximately around 2,000 artificial satellites orbiting the Earth which relay analog and digital signals carrying voice, video, and data from one or many locations worldwide. Now let's have the third question. How can infrared radiation be detected if it cannot be seen? Well, infrared radiation cannot be seen by our naked eye or unaided human eye. But infrared radiation can be detected by electronic sensors such as camera lenses that is sensitive to infrared lights. All right. So I hope I have answered your questions. And for those questions that were not chosen, it will be entertained by your subject teachers on the follow-up discussion tomorrow. So great job, students. Can you give a thumbs up to all of you who participated in our discussion today? May I see a thumbs up react? All right. So again, this is Ma'am Maylene. Thank you for listening. Science is not boring. Science is fun and exciting. Have a good day and